Viewers like you make this program possible. Support your local PBS station.
This is the story of energy, humanity's single most important resource. Energy is the force that built our modern world, but it's often invisible to us, hidden in plain sight. Before modern energy, people had to walk miles to get water, carrying it by hand or on their head. With a modern energy system, we can move water with an electric pump, freeing up precious time. Once water is plentiful, we can grow abundant food. And with abundant food, there's extra time for education. Educated people have access to economic prosperity. Some can even operate a business and accumulate wealth. With money, more people move to cities where there's more to do. Cities need transportation to bring goods back and forth. And people are more likely to travel to see the world. All of these luxuries give us a quality of life worth protecting and even fighting wars over. As a society, we're making decisions about energy that will impact our planet for centuries. So we must understand it. And we can understand energy by looking at transportation.
The ability to travel equals freedom. Cheap oil changed the modern world in so many ways. And the oil age came upon us together with the internal combustion engine.
The discovery of new sources of power allowed us to develop sustained growth. People are really looking at growth and development and starting to question that and saying, actually, is this the right way to go?
As we are able to find new sources of energy to make it cheaper to travel longer distances, it opened up the possibility to live a little bit further away from where you worked. It started with horse-drawn trams, and then it moved towards elevated railways here in New York, moving people between Lower Manhattan and the rest of the city.
Once upon a time, if you grew up in Somerset and then you moved with your husband to London, you'd never see your family again. I mean, it's just too far. You hardly ever go and see them. It's miles away. Now, you can go on the train all around the country and you see the beginning of day trips, of holidays, of families really moving around for work. And all of this is thanks to the Industrial Revolution.
The downsides are that we've now built our modern society around the car. These highways crisscross the nation, dividing societies, cutting up the land. There's pollution from the cars themselves.
Transportation is one of the biggest consumers of carbon-based fuels here in the United States. Gotta be able to figure out a way to get more people per vehicle, per lane of traffic, and that's just math.
It's an enormous issue that has to be addressed. There is no solution to low carbon without addressing it in transportation. We are going to need the fruits of innovation. We're going to need some home runs, frankly.
This is Power Trip, the story of energy. The desire to explore is one of the defining aspects of humanity. Transportation, as an expression of our explorer's instinct, is a very human act. But transportation has always required energy, and the energy we use for transportation has changed over time. Centuries ago, if we wanted to travel anywhere, our options were limited to using muscle power, using animal power, or wind power. But in the 13th century, an English philosopher, Friar Roger Bacon, made predictions about transportation which must have sounded strange. He foresaw that someday we would have flying machines, motorized carriages, and ships. Roger Bacon predicted modern transportation. His fantasies became a reality because of the magic of energy. As a result of technology innovations, travel was democratized. The ability to travel equals freedom. Transportation has shaped our societies, And as its vehicles change, our concept of place changes along with it. Energy has made transportation possible.
Centuries ago, most people didn't travel very far, so mostly they traveled on foot. When they didn't travel on foot, they used animals to draw wagons or to sit on. Some people, of course, did travel long distances, but that was a very tiny proportion of the population and powered by animals.
Eventually we started to sail. We would harness the wind to move our ships.
Of course, there was ocean travel, but when people navigated across the ocean, they stayed close to shore because they didn't have navigation devices. So we've been in a constant state of change and innovation throughout history in the field of transportation.
Sailing's one of the oldest forms of transportation beyond muscle power, using your own feet or using the power of an animal, for example. Today, we're gonna go sailing. I'm gonna learn how to harness the wind for transportation.
Dr. Weber.
Nice to meet you, Michael Weber. Thanks for taking me out today.
Oh, pleasure, man. You ready to start sailing?
Yeah, let's start sailing. I guess I'm as ready as I'm gonna be. One of the challenges with sailing is that the wind is constantly changing. It's the only thing you can count on. And knowing how to capture the wind the right way to get your boat where you want to go is not easy.
Where's my wind coming from?
Feels like it's over here. Yeah.
Good.
Big winds out here, guys. Real big.
All right, Michael, now we're going to teach you a bowline. This is a sailor's knot. Your bidder's going to follow the load.
All right.
So you're going to go over on yours, and I'm going to come under on mine because my load is on the bottom.
Yours on the bottom. Mine's on the top.
And Doc, you're coming with me, man. You got no choice.
And the more we pull, the tighter it gets,
The tighter it gets.
We're not even sailing yet. This is all just for prep to sail, right?
Lot of prep, Michael.
Yeah,
Lots of prep with this.
It's a lot of hard work.
Speed is key.
Oh, my God. I need more exercise. I'm not...
Go, Michael. Go fast, Mike. Fast fire. You got it, Michael. You got it. Keep going. Oh, and you feel that?
I feel it,
You feel
yeah.
that burst of energy?
Almost there.
Wait, yeah!
You feel the wind?
Dang!
It's a good day for sailing.
Awesome day.
All right, there we go.
Awesome. Speed's looking good, Will. Now, the first thing you need to know about is that you have no brakes.
Oh, okay, now you can tell me.
Humans have tried for centuries to use waterways to move heavy goods. Canals were built as a way to simplify and enhance transportation across continents. Much of the economic growth of the United States during the 1800s was tied to the development of canals.
Moving between states now, we take kind of trivially, packing up something on a small pack boat and moving it downstream and trying to trade that in another state. Before the Constitutional Convention, you would have had to change currency, you would have had to go through tariffs in order to move between those different states. And rivers kind of made it to where if we wanted to have an economy, we knew that we were going to have to move things around by rivers. And we said, well, we ought to make it so that that's a lot easier.
When we think about how the city of New York evolved from a small waterside city to a global metropolis, it started with the construction of the Erie Canal. And the Erie Canal linked the Great Lakes region and all the products that were upstate in New York, brought that down the Hudson River via the Erie Canal into New York, and that made that a kind of a global way station of products that were moving around the country. And so it's a lot easier to move something on the water than it is on land.
Access to water is one of the defining elements of a civilization. Because of the importance of water, sometimes we would intentionally build waterways to facilitate the movement of goods. We would build canals. That was before automobiles, and some of these canals exist today that were built a long time ago.
Now the desire for commerce led to something new and revolutionary. In 1807, Robert Fulton built a ship without sails. Powered by steam, the Claremont traveled up the Hudson River from New York to Albany and introduced a new era in transportation.
Transportation has helped shape the growth of nations. Thanks to trains, automobiles, canals, and planes, our world is more interconnected than ever before. The fuels and forms of energy we use always changed and have enabled the machines to propel us forward.
We're in the Museum of Science and Industry in Chicago. It's one of my favorite museums in the world. And if you talk about the history of science and the history of industry, you have to talk about the history of energy. This steam train has the locomotive or the engine at the front and then the tender behind it. Energy is used in the coal to power the motion of the locomotive, but it's also in the steel. This device in front plays a very important role, which is to move cows and other brush off the tracks.
Often, I think we get so excited about electricity and we think that electricity was the great invention because it is so magical. But steam, which maybe isn't quite so magical in its look, is just as transformative. When the people realize what you can do with steam, well, there's no looking back.
Modern energy revolutionized transportation by fueling the steam engine. The limits of wind, currents, or muscle power were finally overcome. The steam engine rose hand in hand with the Industrial Revolution because of its breakthrough ability to turn heat into motion. The first practical steam engines were developed to pump water out of mines. But it was James Watt who improved the steam engine so it could be used for much more.
What you see with a Scotsman called James Watt is he transforms everything. He creates the first efficient steam machine.
Watt's designs were adopted by the textiles industry, helping launch the Industrial Revolution. They also enabled the rise of steam-driven ships. Steam-powered trains were also transformative because they could reach landlocked destinations far removed from waterways suitable for navigation. They also were much faster.
This long round tube up top is the boiler where it would burn coal to make heat to turn the water into steam. The high pressure steam would come down here into a chamber with a piston inside the cylinder, and that piston would move back and forth with the high pressure steam pushing it. And as that piston moved back and forth, it would push this rod back and forth. So we're taking chemical energy in the coal at the back into thermal energy here to make heat in the steam, which gives us the motion and mechanical energy here to move the wheels.
Trains changed the landscape once again and made history. In America, cities would pop up seemingly out of nowhere because the train arrived.
The steam train and the steam ship really transformed some landscapes. In particular, thinking of like the American continent, what trains and steamships did to the Mississippi River or to span the continent. People like Leland Stanford and Commodore Vanderbilt made a lot of money building railroads that could move goods and people long distances quickly with a system of rails and steam trains that would ride on top. And those steam trains were powered by coal.
The steam engine was also used for personal transportation. One early automobile was called the Stanley Steamer, invented by the Stanley brothers, Francis and Freeland. The car had a water tank that would need to be refilled as the steam was slowly vented during operation. The car set all sorts of speed records, achieving 130 miles per hour in one demonstration, and was very popular.
The impact of steam, of electricity, of the movement of new power, this impact of this on the average man and woman in the street, well, that's huge.
Energy has lowered the cost of moving from place to place. So with increased efficiency, we have lowered the amount of effort that it takes to cross space, and we've taken advantage of that by expanding all of our activities in space. So people today travel over much larger distances because of modern energy and the technology that allows us to use that energy.
It changed the nature of work, it changed the nature of wealth, it changed the nature of property ownership, and it also changed where we lived. We had a rise of movement from rural areas to urban areas, and with the rise of cities came the concentration of people.
So we're moving along at what, 2 miles an hour? Most New Yorkers are walking at a pace of 4 or 5 miles an hour. This is one of the reasons that folks wanted to put transportation in New York underground. The New York system has about 5.7 million average weekday riders, or more than 1.7 something billion riders per year. And where we're going to Times Square is the busiest station. We're at 42nd Street, 7th Avenue, Times Square. Before the subway was up here, this was, mostly where we stored horses in New York.
In 1870, most people in cities lived at very, very high density.
There was a need for people to get from place to place, from home to work, from work to the store, from the store back to home, and that kind of thing.
So we first had horse-drawn public transit vehicles introduced in the 1830s or 40s.
We think of horsepower, that literally comes from how many horses that you would need to move something. And in Brooklyn and Manhattan, at its peak, there was 100 to 200,000 horses moving people and goods around the city. And with horsepower comes horse manure. And so now you had this huge pollution problem.
And horse manure was all over the streets, and dead horse carcasses were all over the streets.
Each horse producing 15 to 30 pounds of manure a day times a couple 100,000 horses, and you have a big problem. The streets were a hellscape.
The flies and the smells and what would happen when it rained and people walked through it.
You would need approximately 250 of today's garbage trucks to move all this horse manure out of the city every day.
It became very difficult to get everyone around just by horses and horse-drawn carriages because the horses would generate so much manure. It was hard to solve the mass transportation problem.
It was pretty clear to the politicians at the time that if we're going to keep growing, we're going to have to move to some sort of rapid transit.
The 1800s were a period of very rapid technological innovation in transportation.
The city of New York was growing, but most of the folks were living near where they worked. They were living in downtown Lower Manhattan. It wasn't until the omnibus, which is a horse-drawn stagecoach, was able to move some commuters a little bit further north than Lower Manhattan.
In the middle of the 19th century, New York City had become a crowded mess. There were many proposals for a public transportation system. The first attempt at an underground system was developed by an inventor, Alfred Beach, in 1869, running on pneumatic power. His idea was that air pressure from massive blowing fans would push a streetcar back and forth along an underground line. After only 2 years, the pneumatic tunnel closed, and the idea of an elevated train won out, followed by the subway.
The heart of any railroad system lies in the city. This is the last stop and the beginning of another run.
It started with elevated railways here in New York, full-size coal-powered locomotives moving people between Lower Manhattan and the rest of the city. One of the challenges with those is that you had smoke bellowing from these elevated railway cars, and it was noisy. So to live in a city where you have an elevated rail car barreling down the middle of an avenue started to get unpleasant. If you want to understand the subway, you really have to understand the origins and the beginning of how this all came together. So this is a mode of power, right? This is the traction power for a subway car. This is the engine of the subway. So this sits underneath of a train car. Electricity is fed from the third rail.
That's the third rail right there.
So it's good practice to never touch a third rail, even if you know it's not electrified. So I won't kick it for you, but you can see this mode of power connects with a small metal bar and slides along this electrified third rail. This is how we take electricity from a fossil power plant and move us down the line.
Early in the subway's history, the trains were powered by burning coal or diesel right on the train, which produced fumes and smoke, making tunnels unsafe. Later, the subway became powered by electricity. Electricity still relied on burning fossil fuels, but out of sight and out of mind of city dwellers.
When the subway opened in 1904, It was like New Year's Eve in New York City. It was, by all accounts, an enormous success.
I like sort of the mosaic tile signs and
this
decorations.
is something, that was emblematic of the original subway, is this attention to detail, the ornate tile work.
It's like a public art.
Suddenly, when rails were put down, the horses were eliminated when electric motors were added, and streetcars spread all over metropolitan areas all over the world.
Subways transformed cities because they facilitated the mass movement of millions of riders without taking precious real estate or farmland on the surface. One observer noted that the subway made New York City what it is today, bringing rich and poor people of many races and backgrounds together. Today, electricity in the New York City subways is generated by a mix of fuels, including natural gas and hydroelectricity. The electrification of mass transit created a vast underground ballet, a coordinated movement of people and machines.
Initially, the subway was very profitable. What happens is when you cram all of those people in the subway, you're going to start to have overcrowding, you're start to have things breaking down. And in the 1960s and 70s, the subways fell into a state of disrepair. Starting in the 1980s, and there was a period of reinvestment in the subway, brought it back up to a state of good repair, and you started to see ridership grow again. There are 466 stations, there's over 700 miles of track.
It's amazing to me that the subway, which is out of sight below ground, changed the shape of the city above ground.
New York City was built first with the Erie Canal, and then with the birth and the growth of the subway system. And so that's what really has shaped the way that we think about New York City right now. And transportation is going to affect the way that New York City grows in the future.
In a subway system like in New York, it really transformed the city because it meant millions of people can move around.
Here in the city, days and nights are filled with the sounds of speed. Electric trains above the streets on elevated tracks, roaring through miles of tunnel underground. In those days, the first gasoline buggies were giving speed to everyday transportation. Automobiles that seemed at first to be a joke began in the early 1900s to take over the roads and take over the transport load that had been drawn by horse.
The next revolution happened with the internal combustion engine. The internal combustion engine was invented towards the end of the 19th century. Otto and diesel created the Otto cycle and the diesel cycle, which are the two main power cycles still used by modern engines today. The advantage of the internal combustion engine is that it was much smaller, and that made it compatible with a personal automobile. Now it meant individuals or families could have their own form of transportation. The internal combustion engines became products for the masses in the early 1900s.
The internal combustion engine controlled the market because it was superior in many ways. It had a much larger range than an electric vehicle, and it had greater flexibility when combined with electricity in the form of a battery.
In 1903, the Model T in particular was a machine that changed the world. It was liberating, it was freeing for people, and it was democratizing. The price point was accessible, and it was transformative.
The Model T Ford was revolutionary because Ford figured out a way to mass produce the cars, and the goal was to bring a car to the people. It wasn't very fancy, didn't have a lot of options. Henry Ford was famous for saying that customers could have whatever color they want as long as it's black, and people loved him. And that mass production and the assembly line and the skills he brought to bring down the cost really helped drive car culture in America.
What a wonderful feeling it was to own your own car. The Sunday afternoon drive became a national pastime. At first, just being able to drive a car was enough, but pretty soon the novelty wore off and people began to get angry at the bad roads.
People acquired automobiles when the road network was fairly basic. So people would go out on weekends and drive on dirt roads and find very circuitous routes because that was all that existed. And politically, they began to demand paved roads, and they began to demand more direct routes between origins and destination. So automobile clubs began to lobby for paved roads between cities.
So they started to make the roads better. In every state all across the nation, men and machines went to work.
As early as about 1915, in California, about 40% of the state budget was spent on road construction because people wanted paved roads. And yet the automobile was growing in popularity even faster, and they couldn't keep up with the demand. So just 100 years ago, they introduced the gasoline tax, which was a way for paying for those roads. Energy has lowered the cost of moving from place to place, and cost can be measured in dollar terms, but it can also be measured in energy or effort. So with increased efficiency, we have lowered the amount of effort that it takes to cross space, and we've taken advantage of that.
Not only did it save time, it gave the average citizen a wonderful new way to spend the time he saved. There were many new images in the people's minds now, things they had seen along the American road. There was a new look in people's faces, a look of discovery and wonderment and pleasure. A new world had been opened up for them.
Car ownership had been desirable for a while, cars have been around for a while, but the economic crash in 1929 through the 30s really slowed the purchase of cars. Then the war effort displaced the cars with Jeeps and tanks and trucks.
The lessons learned from the assembly line and mass production helped us to win a long and terrible war.
It was only after World War II that the American economy was recovering. People had money, they had the desire, the cars were available, and we weren't in a war effort. And that's when car production and ownership really took off.
We have kept on building, and today this is how the American road looks.
The defining decade of American car culture is the 1950s. That's where the American dream of buying a car, driving a car, going across the country really took off. And that occurred hand in hand with the construction of a national interstate highway system, something that President Eisenhower pushed for and remains to this day the largest infrastructure project in the history of the United States.
The interstate system was first proposed before 1920. In 1956, they raised the gas tax substantially, and that enabled us to actually start building the interstate system. But it took arguing about it from the 19-teens till 1956 to actually start construction.
Route 66 might be the most famous highway in the United States. It travels from Chicago through St. Louis, Amarillo, Albuquerque, all the way on to Los Angeles. The idea of a road trip really didn't exist before that. People wouldn't travel like that just for fun. But with good roads and the invention of motels and a car culture, the road trip began. And this is sort of an epic American moment in many ways. In some ways, the car culture of the 1950s was the natural outgrowth of the Industrial Revolution decades and centuries before. Using machines to give us more liberty and more capability, using energy to propel those machines. Energy liberated middle-class and poorer people from the confines of their hometowns.
As a result of some of the grandest technical achievements in human history, travel is no longer the exclusive enclave of the very rich, powerful, and adventurous. Coal-fired trains, gasoline-powered cars, and jet-fueled airplanes now connect billions of people. The miracles of energy mean that there is a way to get almost anywhere in the world. A select few humans have even traveled to the moon, thanks to rocket fuel.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Air and space travel has been enticing for millennia. Think of the flight of Icarus or the dreams of Da Vinci. There is a famous quote, "For once you have tasted flight, you will walk the earth with your eyes skyward. For there you have been and there you long to return." The internal combustion engine democratized land-based travel, but jet fuels and rocket fuels took us to the future. In the early 1900s, when the Wright brothers demonstrated their plane, they would use petroleum-based fuel to run their internal combustion engine to spin a propeller. And this engine was not so different than like your car engine today. It would spin the propeller would push the air over the wings, and that would give the lift. The propeller had some real benefits, which is it gave you the speed you need to get airborne. But as you go higher, the air gets thinner. And as the air gets thinner, the propeller works less effectively. Frank Whittle changed all that. Frank Whittle was an English engineer who invented the jet engine. And with the jet engine, it uses a compressor turbine system to squeeze air, heat it, and then expand that air through a nozzle to give the thrust you need to get the plane moving quickly. And because it compressed the air, it could work in thinner air. And that meant it could go to higher altitudes, which meant it could go faster and had less resistance because at higher altitudes with less air, there's less drag on the plane. So Frank Whittle revolutionized aviation with the invention of the jet engine, which we still use today. We went from riding horses in the late 1890s to reaching space in the 1950s. In the span of 60 years, we completely revolutionized the world of transportation. Transportation has shaped our societies, and as its vehicles change, our concept of place changes along with it. Energy has made transportation possible.
Every car on the American road, every new building that towers against the sky is a sign of our progress towards a better way of life. But perhaps the most wonderful thing about the American road is the freedom it gives us. You've only to get in your car and start driving to feel it. We have come a long way since the quadricycle and the Model T. The American road stretches ahead of us, all towards a new horizon. We are all traveling along that road, all moving forward towards an even better tomorrow.
The idea that the automobile represented freedom and autonomy goes way back to the earliest days of the automobile, when people were pretty much confined to the inner city. Public transit was seen as a den of iniquity and as a necessary evil. And the automobile came along and, wow, I don't have to do that anymore. Or if they lived in rural areas, they had to stay on their farm. The automobile came along and made it happen.
The motor car has been the key to open new horizons, not for the few, but for all. And all of us share in the responsibility of safeguarding the benefits it has brought. If we plan for the future, the motor car will be the key to our ever-widening horizons of tomorrow.
Back when the automobile was new, it was regarded as an environmental savior. It didn't produce horse manure. Similarly, lower density living at the edge of the city was seen as a place of fresh air. The automobile was even safer as it was first perceived.
The downsides are that we've now built our modern society around the car.
Transportation has evolved in its current form factor over more than 100 years. The automobile took over and proliferated. It's also become its own worst enemy at times. It's moved from an environment where there were maybe not enough cars to a situation in developed countries where the car park can't exceed the population or is close to the population, and all of the resulting problems that result as a consequence of that many cars.
Our cities have been taken over by cars. These highways crisscross the nation, dividing societies, cutting up the land, worsening air quality. The pollution also accumulates in a way that causes global climate change. So there are downsides too that we have to manage. We have to manage the noise pollution, the sight pollution, the water pollution, and the air pollution. I like the liberty, the ability to move, the desire to go to place, and how the cars enable that. So I want the good things of transportation, but without the bad things. And that means rethinking it from scratch.
All right,
Tom, so I'm thinking that for today we're going to start heading over towards the trading station. We can collect some new data over there. And also see the progress on how it's all coming along as well. Sounds like a plan.
Here at Ford, we are absolutely committed to bringing autonomous vehicles to life over the next several years. When we speak of autonomous vehicles, we mean vehicles that can drive themselves without the intervention of a human operator. I think if we look around the world, we're approaching 100 million units of automobiles produced a year, and we're just out of room for cars. We've seen the mega cities in the United States, the average speed of traffic cut in half over a very short period of time, most of that being attributed to ride-hailing that has pulled more people onto the streets and out of other forms of transportation. But we believe autonomy is a key solution. The opportunity to pool very efficiently and effectively in an autonomous vehicle, to lower the cost of transportation, and to complement existing mass transit systems is very, very real. Autonomous vehicles have the opportunity, if developed well, to be substantially safer than the human. Roughly 90% of accidents are attributed to human error. The main body of driving that we do every day, the things we see on the road and normally react to, that's the relatively easy stuff. As you get out to the combination of events that were unforeseen, unplanned for, the machine has to be able to handle that. A lot of that is a learning exercise, but also making the machine robust enough to deal with the unknowns as they happen. We view autonomous vehicles as having the opportunity to continue that legacy of democratizing transportation. It has the great potential to lower the cost per mile traveled, to provide transportation for people who don't have great options today, to increase the environmental friendliness of transportation, to reduce the amount of time and cognitive hours that are absorbed in transportation unproductively. So it's liberating in many, many different ways. If tomorrow we replaced every vehicle on the road in Detroit with an AV, one, the environment would get a lot safer. The cars would be able to communicate with each other. The opportunity to prevent accidents would be tremendous. My personal hope is that if we were to take it back from the automobile tomorrow and have a 100% autonomous environment, that you'd see a pooling and a massive reduction in the number of units on the street, really cutting down on congestion, really reducing the amount of energy expended. The share of society that's given to the car today would be transformative to our street and how we interact with it. Right now, we're using a hybrid electric battery pack for development purposes. Over time, we see this going all electric. We need advancements in the state of battery tech, the resistance to fast charge, and frankly, the infrastructure around charging to improve a little bit before we get there. There is a great natural pairing between EV and AV. It's just not quite here yet. For EVs to really make sense for society, the fuel matrix has to evolve over time. Today, depending on where you live in the United States, you can actually create more CO2 by operating an EV than a traditional combustion engine. Now that's changing over time, right? And in a couple of years, that won't be true. But you have to get to renewables to really make sense of EVs in mass numbers. We have committed a tremendous amount of money and resources to being a winner in this space. There is a tremendous economic carrot. We are probably talking about single greatest productivity improvement of our lifetimes. The average person in the workforce spends close to an hour just getting to and from work. Cognitive time that they could be doing much more productive things with. That's time that you could be sleeping. That's time that you could be putting into your time with your kids, could be put into work. If you think of time as the ultimate human currency, it's a tremendous gift back to humans.
Transportation is responsible for about 25% of global energy consumption, mostly in the form of petroleum products burned in internal combustion engines, which only operate with about 25% efficiency. This means that 9 of the 12 gallons in a car's gas tank are wasted, rejected as heat into the atmosphere, and only 3 are used for propulsion. But if we replaced this with electric vehicles, the economy's energy efficiency would be improved, and emissions would drop dramatically. However, creating electricity today still relies on burning fossil fuels. If, in the future, only wind, solar, and nuclear energy were used for the electricity to charge those vehicles, then about 1.3 billion metric tons out of nearly 6 billion tons of CO2 emissions would be avoided in the United States alone every year.
The greenhouse gas problem is a very tough one to solve, and we simply must resolve it because of climate change. Buildings are becoming more energy efficient. Transportation is becoming a larger share of the greenhouse gases that we generate. Electric and other motive power for automobiles, hydrogen-powered, hydrogen fuel cell vehicles are being touted as the solution. But then urban planners like to argue that we should live at higher densities near public transit stations and use public transit more and walk more.
Stand clear of the closing doors, please.
In 2016, New York had their highest ridership since 1948. More than 5.7 million average weekday riders. The challenge is we're still moving all these people on kind of 1910s and 1930s technology. What's needed now is a new reinvestment in the way that we do rapid transit, not just here in New York, but all around the country, is because we're not going to be able to move people in and around densely populated areas in cars.
There's a Shake Shack, and then over here there's a bagel place, a florist, a sushi and bento box. But so you could actually just hang out here for a while waiting for your train. This wouldn't be so unpleasant at all. So a city might want to put a subway in, and they would look at the bill. It must cost billions or tens of billions of dollars, so they might say it's too expensive. But are there economic benefits from putting in the subway? If you invest that money for mass transit, what do you get for it?
Transportation, and especially efficient and modern transportation, can make good economic sense when it's applied smartly. One of the ways that the subway system was able to get a lot of sustainability into their designs at first was thinking about the station. I mean, and how we heat, light, and ventilate stations, and that's kind of an element of connecting green buildings to transportation. So you can see along the wall there is the heating and air conditioning vents. So you see a lot of LED lights, you'll see advanced HVAC, you have good escalator systems that are modern and use less energy, and then a lot of the big use of natural light.
In the end, I'm very optimistic because all you have to do is look at history to see that the trajectory of change is always toward more efficiency and higher quality of life, and improvements in transportation have steadily contributed to that.
The typical solution to reduce traffic congestion is just to build more lanes. We have some highways in America that are 16 lanes across, yet there's still a lot of traffic congestion. The joke is that trying to ease traffic congestion by building more lanes for cars is a little bit like trying to solve obesity by buying a bigger belt. In a place where the space is constrained and you just don't have room for everyone to have a car, the government is often taking a step to solve it. In Singapore, they control it by managing how many people can have a car. They don't have more room to grow in Singapore. They have to manage their space efficiently.
Singapore is interesting because it's a city-state, and it's a city-state that thinks about its resources because it has very limited land, and so it has to think about what it's consuming and what it's producing and managing its waste. And it does this all in a way with an eye towards the future, so it tends to be a pretty futuristic area.
They can't build more roads, they're out of space. And they know the roads of the current system can accommodate as many cars as they have. And Singapore has a limit on the number of cars they have on the island, so mass transit's very important for them.
There's a lot of traffic, a lot of people here, although I'd say it's not quite as bad as, say, New York City or Houston or Austin. I think they manage it a little more intelligently here in Singapore. They also have a lot of mass transit and ways to reduce the pressure on congestion. Trains make sense anywhere there's high urban density. Places where you have to move a lot of people and don't have much space, trains are really efficient and very compact.
I would love to see train systems, metro systems, subway systems like that really flourish in the United States. Outside of New York and Chicago and Boston, the few cities where they are successful today.
California stands at the edge of having a statewide high-speed rail system connecting Sacramento, San Francisco, Los Angeles, San Diego, and cities in between with high-speed trains, electrically powered.
In the United States alone, 28% of energy is attributed to transportation. So we need something new. We need something that eliminates dependence on fossil fuels, and that's what the Hyperloop is. The Hyperloop was really in response to increasing traffic. You are removing air resistance because you're pumping out all of the air. So your vehicle or a pod can just dart through that tube super fast at over 700 miles an hour. Attach that electric engine to it, and with very little energy, you're able to transport thousands and thousands of pounds. You can move people, you can move goods or cargo from one major city to the next. We need people who are at the front lines trying to figure out the solutions for tomorrow before it becomes too late for our planet and the human race.
The idea is that it would be, quote, environmentally clean. Well, it will be environmentally clean if the electricity is produced by hydro and solar sources and not by coal. We're moving so swiftly toward cleaner sources of the production of electricity that California is now actually paying other states to buy its surplus of solar-produced energy because it's harder to store it than it is to use it, and we're paying neighboring states to use what we're producing. If we succeed in producing electricity from greener sources, then the transportation system can benefit by that and be cleaner too.
To solve the problem of pollution, we're going to need all hands on deck. We're going to need innovation from private industry and entrepreneurs. We're going to need planners at every level, city, state, and federal, to come up with building codes and urban layouts and regional planning that really fosters innovation and efficiency, as opposed to encouraging the wasteful consumption of resources. We need everybody to be engaged on the solution. We need all hands on deck.
Transportation has shaped our societies. Where we travel and how we travel on any given day simultaneously gives order and freedom to our lives. And as the machines we use for transportation change, our concept of place changes along with it. Transportation has given shape to countries. Canals did it in the early 1800s. Rail did it in the late 1800s through the first half of the 20th century. And highways did it in the late 1900s. Autonomous vehicles, if and when they fully arrive, will change the rhythm of our lives yet again. In the modern world, everyone uses energy with a mixture of happiness and guilt. It's the energy lover's dilemma. How do we get all the benefits we enjoy from consuming energy, but without the negative impacts on the planet? How do we experience the liberties of transportation without the pollution? Because each fuel and technology has its benefits and risks, energy managed the right way offers tremendous contribution to humanity. It makes us wealthy, healthy, and free. But energy done the wrong way reduces our security and poisons our environment. Energy lets us explore our land or soar to the skies. Responsibly improving access to the liberating potential of energy is the grand challenge of the 21st century. And we all have a role to play in that story of energy.